Hi, so I'm doing this thing. Hey, um, this is my first attempt at streaming, so please be gentle. Anyway, this is a stream in which I'll create some games and teach some C++. So I've had this idea for I don't know, a long time, and I kept on forgetting about it, and now I guess it's about time for me to start. So let's see where this takes us. As you can see, I've opened something, but my idea is for us to basically start things from scratch. So basically, oh hi Trump88. So to start doing things as if I don't know, it's a fresh install for everybody. And you can see I'm on Windows, but I don't want other people to be left out. So I'll at least keep I don't know, saying stuff which is relevant for Linux or Mac people. But since the setup for Linux and Mac is, I don't know, pretty straightforward and easy, I'll be spending, I don't know, probably too much time in this first stream at least, setting up things on Windows. So basically, this stream is, apart from this welcome message, setting things up on Windows the way I will use them. You don't necessarily have to do everything I do in order to continue using or following me with the stream, but I strongly encourage it, let's say. So first of all, at least in our first attempts or first lessons or first streams, we'll be using Visual Studio Code. I've got it open right here, and I guess you can download it. It's available for all desktop operating systems. Just type, it will take you here. You can download it and install it. It's an editor. It's an editor for code. If you're not familiar with it, it has a lot of features. It's not as good as full-fledged IDEs for development, for C++ development, but it will be enough at least for the beginning of the stream. In time, we'll probably install other things as well. So I'll be using Visual Studio Code, and let's now continue with this. So people might not be familiar with C++, and that was my intention for this stream. So some people watching this, I assume you have some coding background, but not necessarily with C++. And C++ is a pretty quirky and strange language if you don't know it. So I'm going to attempt something quite unorthodox. For this stream right now, I'll be just setting things up, setting the compiler, setting up the IDE, and basically if we manage to do a hello world program, that's basically my idea. So and this is an introduction to game development, and we'll start developing games from the very beginning, starting with plain text games and gradually moving ourselves up to 2D and then 3D games. I won't shy away from using libraries, but no concrete plans for which libraries I'll be using now. So first of all, we need Visual Studio Code in order to write our first attempts in C++. Then, since it is C++, we'll also need a compiler. And again, people on Linux and Macs have it easy. They can set up their compilers pretty quickly. But for Windows, that's not that easy. First of all, our first compiler, and oh yeah, C++ has many different compilers, and since I don't want anyone to feel left out, I'll install a lot of compilers along the way. But first of all, for this first stream, we'll only need GCC. So to install GCC on Windows, the suggested way of doing so, at least, is to start with MSys. So I'll just go ahead and install MSys here. So MSys, you can find it on, you can just search for MSys2, and there's the download links. This is for Windows only again. So you can follow these instructions basically. I go ahead and install it as we speak. So something else though, we'll also be using the terminal quite a lot, and that's something that most programmers do. I don't do it as much as others. I guess I use a lot of editors, IDEs and stuff like that, but the terminal will be present. And for Windows, since the default terminal in Windows is pretty, well, I don't know, shitty, I guess, we'll try installing another terminal. But what am I saying? Okay, I'll cancel that. I'll just choose another directory. You don't have to choose another directory. You can choose the default one, but I usually add my things in just programs, and that's basically it. So okay, that's fine. So a terminal that we'll be using for this stream, and which I use a lot, but I just removed from my PC in order to set things up properly during the stream, is, well, I don't even know how to pronounce it. Mother? I don't know. CMDER. Okay, so that's a terminal emulator for Windows, and it's much better than the default Windows terminal, which is a CMD. You can see it here. It's awful. This one is much better, and I won't be using Bash or any other Windows setups. because they make Windows seem more like Linux, and we'll see why this is not something that we want. Basically, the main problem with using Bash or something on Windows is that it requires you to set up your environment in where everything is part of the Bash packages. We don't want that. We want separate Windows programs for this, and we'll set up our environment in order to use those programs appropriately. That's one of the main differences between Windows and Linux. In Windows, you can, I guess more easily have different environments with different sets of terminal tools working. Whereas in Linux, it's harder. You can do it, but the straightforward way, which makes it really easy to start, makes it actually harder in order for you to have different environments. The suggested way is probably to use something like containers, or you can deal without containers too. Anyway, so I'll be using a Windows terminal emulator and not Bash, but again, some people might prefer to just install and use the MSys Bash, which is what we'll be starting right now. And this, I'll be using this only to set things up to install GCC for Windows. So the GCC package for Windows is, well, let's just, okay, first there were some, setting things up here. I don't do this very often, I don't remember it by heart, so okay. Okay, so there's updating some databases. In the meantime, if you're on Linux or a Mac, for Linux, okay, just let me zoom things. For Linux, you can just start your terminal and check if you have GCC or G++, and if you don't, you'll probably have to install them with your favorite package manager. For Macs, you can just run this in your terminal, xcode select install, and this will install command line tools for C++ development on a Mac. If you don't have these on Linux, you will probably have to install them using your package manager. So if it's apt, for example, you'll do something like, and that's basically it. This will install, and they will be available for you to use. Oh, why? It's asking me questions here. And of course, Visual Studio Code is something else that we'll be using. Okay, this might take some time, and well, in the meantime, I may just install. I'll just keep calling it mother. I don't care. So you can download here. We want the mini download, not the full one. We'll install Git separately when we need to. So this is not an installer, so you'll have to unzip it basically in some directory that you want to choose. So I don't know, I'll keep on using this one. So let's do this. And there's another thing about it. It's basically, it's not a program on its own, whereas it's a program which sets up another program to start. So if you're familiar with Windows, oops, not you. Okay, so if you're familiar with Windows, you'll know that if you want to, you can just pin some programs right here, like this. But you can pin some programs in your quick launch, and if you want to pin this in your quick launch, you wouldn't be able to, because it will pin the actual program which starts from within. So I'll just okay, let's stop this in order for me to have this. I'll just create a shortcut here, and then I can pin this to my quick launch, and this will start the appropriate program. So let's start it. Whoa, full screen. I love my Windows not full screened. Anyway, so this is a terminal emulator for Windows, and it's pretty similar as it is to the Windows command prompt, but has much nicer features in order to for auto completion. It also has Git integration, and when we start using Git, you'll appreciate it a lot. So in the meantime, what happens here? Okay, this is done, so I need to close this as far as I can remember. Oh yeah, closing you, man. Then okay, starting this. Then what was the appropriate step? Okay, updating other packages. SU. Oh yeah, that's a lot of packages. So updating things. So that's basically setting up the appropriate MSys environment. We won't be using this command prompt, we'll be using the mother one. So okay, what I wanted to do right now, so okay, Visual Studio Code, I'm assuming you're installing it or you have already installed it. Kmother, I installed it, then install the GCC for Windows. Okay, so again, for Linux or Macs, that's basically what you have to do, and then if everything is successful on both platforms, you'll be able to do something like this in your terminal, GCC version, and it will spit out some version if everything is okay. That means you can just use the compiler for here. And while this is doing, while this is installing, while I'm setting up the Windows platform, I'll just say some things about compilers, I guess. C++ is a compiled language, so this means that when you write some code, the compiler needs to process it, and then it produces another file. So you write some code, then the compiler does something, processes your code, and it spits out an object file. And this object file is basically a binary, but it's not an executable on its own. So we need a linker and to process the object file, and then this produces an executable. Okay, so with GCC, when G++, which we'll be using, which is the C++ version, it can hide these steps from us. It can call the compiler and the linker internally, so we'll only need to write a single line in our terminal in order to compile C++ code and then produce an executable. But in time, we'll have to deal with other things as well. So again, C++ compiler processes the code, which is typically a .cpp file. It produces an object file. The linker processes the object file, and perhaps many object files if there are many CPP files. And the linker produces an executable. That's, I think, what I want to say about compiling and linking. And again, G++, which we'll be using at least initially, will do most of these things for us without us having to manually call compile and then link. Won't be using G++ for the entire time. That's basically the easiest way to start. We'll move on to other ways of invoking the compiler, using some build system, I guess, using some IDE or something. So what else? I'll continue setting up my Windows environment, and as I said, Windows is pretty hard to set up if you want to have a developer environment, and that's why, I don't know, a lot of developers don't use Windows. But a lot of developers do target Windows, so that's that, I guess. So as I said, I'm using Kmother, and Kmother will, if you're familiar with paths, oops, so that's the most important here, right here. So it adds itself to the path, even though I haven't added it to the system paths manually. So if I add some programs here, or here, I guess, in Kmother mini bin, they'll be executed, they'll be in my path, and I'll be able to execute them just typing their name here. So I'll create something that will set up my Windows environment, but won't be a part of, I don't know, of my user's environment. So when I start Compiler, I will manually set up the appropriate environment for the programs that I need to call. In order to do so, I'll go here and add a new batch file. And batch is a horrible way to write scripts for Windows, but it's the only thing that's basically guaranteed to work on any Windows platform. So let's call it, I don't even know how to spell this. I used to call it like this, but I've never actually pronounced this, so Udo, I guess. Okay, so that's basically what shell scripts are for Unix-like operating systems. Batch files are for Windows. So we'll add some code, and batch is a horrible language, and it's a write-only language. It's not supposed to be read, but I'm using the code from here. I've written it once, and I have no idea what it does anymore. So it's basically supposed to loop through various arguments that you give it, and then execute them. Well, it really is nasty. And execute programs called do dash the name. So since I have this here, if I add another batch file, which will be much more readable, let's call it test. So, and in it we'll write some like this. Then if we go here and say do test, oh, I forgot. Okay, so these are basically the commands that our new batch file can do. Okay, so it's doing stuff, and it's doing what this test program here basically told it to do. So what happened to our MSys installation? Oh, it's done. So now we have to install GCC. How do we do that? Oh, I don't know the name of the package, and Pacman is actually a pretty terrible package manager. Anyway, Mingw is basically GCC for Windows. It's minimalistic GNU for Windows. That's what Mingw means, and it's the way to use the free and open source compiler GNU C and GNU C++ in Windows. It's basically the only sensible way of doing so. There are other versions. There's actually many versions of Mingw, but this one, Mingw-W64, is the actual the most, I don't know, Windows-friendly one. The others, for example, don't include all the C++ standard library, or don't allow you to write code. But okay, what is my toolchain, I guess? Mingw GCC. Okay, that's what I want. Oh, but not. Okay, I'll just, as I said, terrible package manager. I have to type the entire. What, didn't I copy it? I guess I didn't. What should it be called? So dash x86 64 dash GCC. Okay, a lot of packages, and while they're downloading, that's a lot of stuff actually. I didn't expect it to be that much. I installed some stuff from my PC in order to make the stream, but I didn't realize it was that much. So it's installing GCC now, and this will basically allow us to create our first ever C++ program. And you see how long Windows setup takes. As I said, you basically have to do this on, say, Ubuntu or your favorite package manager, say I guess if you're using CentOS or any other operating system with yum, you'll just type yum install gcc g++, and again that will basically be it. Why did I delete that? Say so and yeah, that's how easy it is really to set up Unix-like operating systems. Okay, it's downloading stuff, I guess. Sorry about that, I didn't realize it would be that much downloading. Well, in the meantime, you can basically test if everything's working. As I said, gcc -- version means that everything is okay with your setup, but not necessarily with our setup. Okay, I'll just start preparing this. So I'll create a new batch file here. Okay, let's call it Mingw, which is the appropriate name. Mingw again is the GNU-C compiler for Windows. So I didn't want to do that. Anyway, so we'll set up our paths basically. So set path equals path, and then where the executables are supposed to be, and they are supposed to be in here, I guess, bin. Okay, most of them are already here, so I'll just go ahead and add this, and I'll be prepared to set up my environment here in Mother. I can just go ahead and do it. I'll just add some text here in order which notifies us what's been done. Oh, let's make it even more readable. Okay, how about this? Yeah, it works. So and right now in this particular window we have access to the files. Well, we can call programs which reside in this directory. If we restart the window, we wouldn't be able to. So what's program which is over here? Say G++. Okay, so I could call G++ version, and it appropriately displays some version. But if I close it and open it again, does nothing because it's not part of our path. So we need to do this again, and now it works. Okay, so that's basically what I mean by setting up environments manually every time we start Mother. This might seem like a hassle, but in time I guess I'll explain why this is needed. But also, once we move to other compilers, we wouldn't call this every single time, and it will be much easier. The thing is that if you install different versions of the compiler or different versions of other tools that you use from the terminal, using something like this to manually set up the appropriate, I don't know, collection of software that you're using, set it up in your environment, is the only sensible way to work on Windows. There are others, but I guess this is, for me at least, this is the easiest way. So for example, if I install another version of Mingw or another compiler or another software which do exist for Windows a lot, like for example, if I install Git, which I will for this demo, if I install Git, it will come with its own set of executables like these, and they will start fighting, and I wouldn't know which set of executables I'm calling. So that's basically what I do in order to have the environment in the most, I don't know, minimalistic way, I guess, set for me to do my actual work. It's not that much like the batch script do, I guess, helps a lot. So I just need to type other commands here. So eventually, as you might have figured out, here in we'll be adding more stuff here that will, like, more settings and more scripts that set up the environment. And I'm using batch. Some people wouldn't use batch because it basically works on every Windows platform, so I don't have to install other languages like Python or Ruby or whatever. So what happened here? Are we done? Yeah, we're done. So basically I close this and never open it again, I guess. And now I think we are ready to start our first program. So I'll just go here for Windows, but for Linux you can, okay, well, you know what? I'm just going to start a Linux virtual machine in order to show the entire setup on Linux too. Okay, I don't need this window here. I need this window here too. I need this one. So Linux is still booting. I don't need this or this or this. I'm going to set up a directory in which the project developed in this stream will reside, I guess. So this directory, I'm going to call it, I don't know, Gamedev stream, I guess. Gamedev stream, how does it sound? Okay, Gamedev stream sounds good. So here we're going to be creating our first C++ file. So to start working with Visual Studio Code, we need to open a directory. So let's go here to G and open this one. It's empty, but Visual Studio Code knows it's empty. So let's create a new file. Our new file will be called hello.cpp. It will be our first ever C++ program. Oh, in the meantime, the Linux booted, so I just do this. And if you're on Linux, for example, you can type GCC version. This is Ubuntu, by the way. I do have G++, or G++, I guess. I do have this here, but some minimalistic Windows Linux installations might not have it. So again, you'll have to install it. And our first ever C++. So basically in Linux, I'm sorry about that, you can create your directory, say, I don't know, projects. Do I have a project directory here? Oh, I do. So I will using PRJ here for short for projects, so you can basically create a directory for the executables and sources that we're going to be developing. What was it? Gamedev stream, and we'll start working here. So you can, again, on Linux, and it's basically the same on Macs too, so the same commands. So on Macs, you can create your own directory here, and you can start Visual Studio Code and go open directory and go to this directory and do like I did, new file, and then call it hello CVP, I guess. So we'll start by typing include eostream. So in C++, in order to use the standard library, you need to include different files from it. Like include means basically tells the compiler that we'll be using the declarations in this standard library header. Those files are called headers, and I'll probably be I don't know, dealing with them as we go. Oh, I did want to mention that my approach to teaching C++ in this stream will be basically doing stuff as we go. Like not any structured lessons. Like today we're going to be using, we're going to be learning about classes or about functions or something like this. I assume that people watching this stream do know about what functions are, at least theoretically. So I won't be explaining what functions are, but I'll be writing C++ code and basically trying to explain what I'm doing while I'm writing it. So what does this do? This means that we are using the declarations in, and you can recognize standard library headers by the fact that they don't have extensions, and we will be dealing with extensions later. So this is a comment. Yeah, C++ does have comments, of course. You're probably familiar with some C-like language, so I won't be dealing with that that much. So now we need to define our entry point for our program. So that's the main function, and int here means that it returns a number. And return 0 tells the operating system that our program executed without errors. So in this case, 0 means no errors. You can, if you're familiar with booleans, which 0 means false, you can basically interpret this as, did this program have any errors while executing? Now, this is useful in some cases, but I don't think we'll be dealing with those anytime soon. Just remember that return 0 is basically the program completed its execution without any errors. So the standard library of C++ defines different symbols, and it does so in a particular namespace. So namespace is basically a group of symbols, of I don't know, declarations, which can be accessed, like say if I have a namespace called my namespace, and as a function we decided called foo, I'll do this. So my namespace : foo means I'm invoking the symbol, I guess, foo, from the namespace my namespace. So we can access stuff from IOStream, for example, and for the entire C++ standard library with std, which is C++ people pronounce it stud, like, or stud or stud or something like this. Nobody says std because of certain, I don't know, medicinal reasons, I guess. So stud : something will access something from the standard library. But in our simple examples, it's too much typing, I guess. So in a simple example, it's perfectly acceptable to just import all the symbols from a given C++ namespace within your global scope. So visible from anywhere, I guess. That's what global scope means, visible from anywhere. So if we type using namespace stud, this means that under this line, every symbol which is in this namespace will be accessible. So this cout, and here we start with the quirkiness of C++, I guess. C++ is a pretty quirky language because it's the way the standard library expects you to output things in the terminal is pretty strange and I don't know, unexpected. So you do it like this. So cout, then this sign, which you might recognize as a bit shift or just less, or open angular bracket, I guess, I don't know. Hello. So oops, I'm covering this. So \n means just a new line. So this is a special symbol in C++ strings. You can, and in every other language, I guess, so I don't know why I'm explaining this much, but you probably know that this means a new line. So this line right here, and if I hadn't written using namespace, I could have written it like this, and it will be basically the same, but I did write using namespace stud, so this symbol is visible globally. Basically outputs the text hello to our terminal window. It's strange, but I guess we'll have to just deal with it for now because it's the quickest way to output things in C++. There are others which aren't that unorthodox, I guess, but you can imagine like this is go in this direction to the output, to this console output. Okay, cout means console output, so go put the things right here to the console output. So console is another way of saying terminal, of course. So this is our first ever C++ program. So how do we actually run it? Using our very basic setup that we have right now, we can just use G++ in order to compile it and run it. And you do it like this: G++, then the name of the source file that you're using, in our case hello.cpp, -o, which means output, say you can call it hello. And the compiler did its job, completed without errors, but let's add some error here. So I intentionally added an error to the code just to see what will happen. And you can see the compiler told us that at line 8 there were some problems. Ret is an unknown symbol to the compiler, and it doesn't know what to do with it. So again, we can do it like this: return 0, and it's valid C++. And now we can execute our program. Oops, I didn't type it correctly. Okay, in Linux. So let's just do the same in Linux, just in case. And I don't have Visual Studio Code on my Linux, and I'll be using Nano, but it's a terminal editor, and you can just use Visual Studio Code if you're following this on Linux. So again, I can type the exact same thing: include IOStream. So this is the standard input-output header for C++. Again, using namespace stud, because I don't want to type stud : every time. Int main. Okay, so I don't have my Nano set up correctly here, but anyway, so I'll just be using it for this simple program. So from Linux, return 0 again, close bracket, then we can save and exit. And again, it's the very same line in Linux and Macs. You can, after creating hello cpp, you just do G++, this file, and then the output is, say, hello. It compiled without errors. Okay, and it executed correctly in the terminal. That's basically what we wanted. So I guess we have our most basic setup for all operating systems, and we can continue using Visual Studio Code. So let's create a very, very small game, and that won't be anything flashy. It will be a silly terminal-only game which will teach us the basics, I guess, of game development. The very, very basics, because there will be no graphics involved whatsoever. So let me just create another file here. Let's call it, I don't know, the simplest game we can create in C++ in a matter of minutes, I guess, is the higher-lower game. Higher-lower, if you're not familiar with it, and you should be if you're ever a 4-year-old child, is where one player thinks of a number and the other tries to guess it, and by saying random numbers, I guess, and the player who had thought up of a number responds with higher or lower depending on the number the other player suggested. So say I'm thinking of the number 7, and you suggest 3, I say higher because 7 is bigger than 3, then you say 11, I say lower, and basically doing like this until you guess my number. And that's a very simple game which we can create in several, I don't know, less than an hour, I suppose. So again, for this game, we'll be using the input and output. So we include IOStream. We won't be typing stud : every time, so just using namespace stud. We'll have a main function. our entry point, basically what gets called when we start our program. Let's first assume that the player is trying to guess the number which is devised by the computer player, I guess. Okay, I have a question here. How my autocompletion works? I have plugins installed. Oh my god, I forgot to tell you about the plugins. So I have the C++ plugins, Control-Shift-P, I guess, install extensions. So if you press Control-Shift-P in Visual Studio Code, it will suggest some extensions. The C++ extension is something that will parse your include files, and it will produce autocompletion appropriately. So yeah, do install the C++ extension. It installs in, I don't know, seconds. So and it will just automatically allow you to reboot Visual Studio Code. So that will basically be it. But I'm not using Visual Studio Code. I could, but I'm not doing it right now. Oh, the autocompletion in the terminal. So again, the autocompletion in the terminal is done with tab. Okay. Yeah, I don't think I get the question. Are you asking me about how I do the autocompletion in the terminal window? Because the autocompletion in the terminal window is just done with tab. So I just start the say G++. It tab, it auto-completes it, so then hello dot, because it doesn't know if I'm talking about hello.cpp or hello dot, okay. Let's continue with the game. The computer player presumably has thought up of a number. So int in C++ means declaring an integer, a number which is an integer. It's a whole number. It's not fractional. So my number, and I'm writing this code from the point of view of the computer player. So my number equals 70. Okay, let it be 78. So that's the number which the computer has thought of. So now the player is supposed to guess it, and in order for the player to guess it, we can just let the player suggest a number. We can output this. Ooh, I forgot that. Okay, so we can output this. Human ask me a number, and now it will ask for a number, and in order to read input from the terminal, from the console, we use cin for console input, and we reverse the direction of the arrows in order to use it. So let's say we call this a human number. We don't have this variable declared. In C++, you do have to declare every variable before you use it. So it's an integer, the human number. So we can just do this. So what does this do? We're asking for we output the text asking a number, and see there is no new line after it. So the caret, it's a caret. I don't know how to explain it. The cursor will stay on the same line. Then we okay, let's just do this for better readability. And then we read the number entered by the human. So this will stop reading once the user presses enter. So, and now we can do the most basic thing. If my number equals, and note the double equals. In C++, a single equality sign means that we are assigning values, and a double equality sign means that we are comparing values. So if my number equals human number, you got me, and new line. Else, okay, that's the first. That's even sillier than the higher lower. So the human has a single chance of guessing the number of the computer, and the computer responds appropriately. So let's just compile this. I just call it HL, it's easier to type. So I compile this, I call HL. So human, ask me a number. I'm being asked, so I type 87, enter. Nope, I didn't guess it. But I have the benefit of actually knowing the code. So if I restart the program, so HL, and to invoke commands that I've already typed in the terminal, I press up and down. And again, that's true for all operating systems. So up and down, up to go to previous commands, and down to return to the next ones. So ask me a number, and I know it's 78, so you got me. Okay, that's a very silly example, but in order to play the higher lower game, the human player will have more turns. So and this takes us to the most essential part of a game, or most software actually, is the game loop or the main loop. So most software doesn't just do, okay, well, I don't know if most software is appropriate to say here, but most software that you're used to using, I guess, has this endless loop within it. So let's call it while true, I guess. And this is a loop without a breaking condition. And in this loop, it processes the input from the user and does the appropriate actions. And then continues to the next iteration, which processes more input and does more actions, or just idles the program. It literally does nothing. For example, Visual Studio Code, for example, which is a graphics user interface program, has a loop inside of it, which if I do nothing, which I'm doing right now, just blinks the cursor. And if I'm typing, it processes this input and enters it here. So a lot of software doesn't just start by executing something and then outputting the result, but instead has a loop. And that's, in our games, we call this the game loop. The game loop is basically the main part of the program, which loops and reads user input, produces some output. In most games it's a graphical output, but we won't be dealing with graphical output anytime soon. So we have this game loop. So this is while true, forever. Do something forever. So what will we do forever? We'll have the human ask us the computer, the program. So human asks. This is a function, so I'll create this function right now. Let's do it. Actually, you know what? Let's make it a bool function, and this function will return true if the human has guessed our number, and this will let us basically break the loop. So human asks. Again, this here means that the function returns a boolean, so it's either true or false. This is what a boolean type means in C++. So human asks, and we can just reuse our code here. I just pasted it within this function, and okay, so if the human has guessed the number, let's just comment this. Oh, there's a problem with my webcam. Oh, it does nothing. Ooh, yeah, indeed. I'm sorry about that. Just let me do this and then this. Okay, no effect, I guess. Nope. Yeah, indeed. What's wrong with you, webcam? Very strange. Okay, one more attempt. Nope. Yeah, troubleshooting. Well, I won't waste any time on this. Yeah, I saw it several minutes ago too, so I won't waste any time on this, and instead I'll just hide my pretty face. How about that? So, and you can see my date, I guess, in Bulgarian, my native language. So just that it's not distracting. Sorry about that. I'll have to figure it out later. Where was I? Okay, so the human in this branch here, the human has guessed the number, so we return true. Again, if the human guesses the number, we return true. And in this branch over here, we return false. The number hasn't guessed the number. Putting a girl or a cat instead of me will take too much time, I guess, but okay, let's try it. I'm doing stuff on my other screen. Okay, that seems fine. No. How about? Okay, how about this? Okay. I'm doing stuff on my other screen and you don't know what it is. Okay. Okay, that's Boaty McBoatface. So okay, that's not distracting, right? Where was I? Oh, a picture. Okay, boats help, I guess. So again, human guessed the number, return true. Human didn't guess the number, return false. So we can put this here in an if, and an if. So if, okay, so the function is in the if, and if the human has guessed our number, we can just break the loop, and this breaks the loop over here. So this is an exit condition. The human has guessed the number. So how about that? We can build, we can start, ask me a number, something, something else, something else, something else, something else entirely. And if I guess the number, which I know what it is, I won. So again, another silly game in which we just try to absolutely randomly guess the computer's number. Okay, so let's do something else. How about we don't initialize this? So in C++, that's another quirky thing about the language. So if it's in global scope, this variable here is not in any function, so it's in global scope. And if I don't initialize it, it will be 0. And I can just add this here. Okay, if you want to output several things, you just use the left angle brackets, the bit shift, this silly operator here many times. So my number is, okay, I'll just comment this out. That's Control/ in order to comment things out in Visual Studio Code. So I'm just outputting the number of the computer. So and you see it's 0. That's for global variables. But if I had a variable here, okay, let's call it my2, and I don't initialize it, it won't be 0. And that's another, okay, this time is 0 because it's in debug, and okay, long story. Typically, it won't be 0. You shouldn't expect a local variable to be 0. In this particular case, it is 0 because the default way G++ compiles programs is to actually make the stack 0, to nullify the stack in order for us to catch bugs more easily. But let's just do this. If I add optimizations, so like this, it won't nullify the stack. So, well, lucky me, it's 0 again. The thing is that this number doesn't necessarily have to be 0. I'm sorry that I wasn't able to produce this example, so this wasn't rehearsed in any way, but a local variable which is in a function shouldn't be nullified. You shouldn't expect for it to be nullified. But global ones you can. So you can expect them to be nullified. So if I type my number here and just output a new line, I guess. If I output my number here, and it's global, like this one here, it should be 0. But the thing is that we don't want the number to be 78 or 0. So we want for it to be something random. And in C++, there are many ways to produce random numbers, but the easiest one, and the one that we'll be using for the foreseeable future, is rand. Rand is a function which returns an integer between 0 and rand max. Oops, underscore I say. Rand max is typically about 64,000, so not a huge amount of variety, but that's the easiest way to produce random numbers in C++, though not the preferred way. There are others, much better ones to produce random numbers. But anyway, we'll be using this. In order for us to use it, we need to include another part of the standard library, which is called cstdlib. So this means C standard library. So cstdlib, I guess, if I continue pronouncing this stud in this context as well. So so that's a function which is also available in C. You should know that C and C++ are different languages, but C++ does have, it's not strictly a superset of C, but it does have access to the entirety of the standard library of C. So this function rand is available in C too. So if I say my number equals rand, it should produce a random number. I don't need O2 anymore though. It's faster. O2 means add optimizations. C++, the compiler itself can optimize your program. And we'll be talking about optimizations a lot, hopefully, later. But for now, this is the simplest way to compile. So, like we said. So it's 41. If you run it again, oh, it's 41 again. And this one, this particular thing here, I am expecting. The thing is that rand produces, I know, a sequence of numbers which is always the same, and this is not helpful at all. So in order to make rand produce different random numbers, we need to seed it with something. So if we seed it, we seed it with srand, and if we seed it with something like another number, we compile and run. You see the number is different, but again, since we seed it with the same number, the sequence will be the same. And I can just try several. I just pasted a bunch of rands here and outputting every one of them. So the sequence will always be the same because the seed is the same. If I change the seed, I'll have another sequence, but in each run of the program, it will also be the same every time. So back when people used to use srand and rand, they were seeding their random numbers in order for them to have a different result every time with the time. So right. Oops, I'm going to have to include. Okay, so time is a function which returns basically the number of seconds which have passed since December 31st, 1970 or something like this. I forget what Unix time is. Anyway, this argument here, or I can just use the C++ way. So it has an output argument. So in C, some functions, or in C++ too, I guess. So some functions can besides returning some value, they can fill some variables that you've set as arguments. And in C, this is done by pointers, and we'll be talking about pointers later, but basically you can just remember this means that we don't care about the result from here. Time will actually fill a specific type for us to use in order to deal with time in C, I guess. But that's the most straightforward way of just getting Unix time. And so what does this line mean now? So we use the seed for the random number generator, the number of seconds which have passed since some date in the 70s, which presumably will be different every time we start our program. So if we build now and do this and this and this, see how every time the output is different. But if we somehow execute the program really quickly in a matter of 1 second, you can see I just this in Windows I used AND to start two things from the same command line, and in Unix, so in Linux or Macs, you will use 2 ANDs like this. So if I start the program 2 times in between 1 second, the output will still be the same. So the sequence will be the same. That's some funny thing about random number generators. Anyway, but in this particular case, in this silly program that we're writing right now, we don't care. So I'll delete this and this and this. And now the number of the computer is always different. Oops, I deleted the seed too. Okay, I'll just retype it. No, I won't. Control Z basically undoes my changes. You're probably familiar with Control Z. What am I saying? So, okay. I'm setting the number, and I'm setting the random number generator and producing a new number for the computer. So let's build this. And I have basically odds of 1 over 64,000 of guessing it. So I'll just terminate the program using Control C. So Control C in all operating systems will terminate the program as it's running. So while I'm developing my program, I'll do something which wouldn't be part of the release. So when I release the game, the following line wouldn't be part of it. But in order for me to debug and actually test how the game is doing, I'll just output the number here. So from now on, when I start the program, I'll know what the computer number is, but I'll be playing along, I'll be playing as if I don't know it. So let's build again. Let's start. So that's the number of the computer. I'll try some different numbers. Neither of them is this, but 2242 is the one. Okay, let's start again. Starting some numbers, but 2271 is the number. Okay, I keep on winning. I'm so good at this game. But still, this isn't higher or lower or something. So let's continue. So okay, we have the human number here. So we should change the conditions. So if the human number is bigger than my number, I can just say go lower. Else if, and in C++ this is how we write else. Some other languages have words like else if or elif or something, but in C++ in other similar languages, I guess you type else space if, and this is the else, and then another condition. So if the human number is smaller than my number, I can just say higher. And if neither of those are true, that it's neither bigger or higher, that means that it's basically my number. So it's not bigger, it's not higher, it's not lower, it's my number, it's the number of the computer. So we can just say you got me, and then we return true. And instead of typing return false here and return false here, we can just type return false here. And that's the dry principle. Don't repeat yourself. That's a big I don't know, that something very important in writing code is that you shouldn't repeat yourself. That if you can write the minimal amount of code possible, you should, well, if you, that's not the correct way to say it. You shouldn't write the same thing multiple times if you can write it once. So instead of, for example, if you want to do something multiple times, you add it in a function, or you write your code in such a way that you only write it once. Because if it needs to change, you only need to change a single place. And in such small programs, of course, you wouldn't feel that this matters a lot, but the bigger your program gets, the more benefits you have from, I don't know, adhering to the DRY principle. DRY, don't repeat yourself. Okay, so we return false. That means the human hasn't guessed, and here the human has guessed. The human has guessed our number. Okay, let's see how this works out. Okay, so we know the number, so if you write a bigger number, lower, we should go lower. Okay, if you write a smaller number, we should go higher. And now we guessed it. And now we can even venture playing without knowing the number of the computer. How about that? Okay, we don't know the number. How about 7,000? Lower. Okay, how about 2,000? Higher. Oh, that's 200. How about 2,000 then? Higher. How about 5,000? Lower. How about 3,000? Lower. How about 2,560? Higher. How about 2,000? Higher. Lower, so I almost have it. Oh yeah, I did it. Okay, it works. Okay, I'll just return this because I don't want to play like this every time. So, okay, but I managed to play a game and actually beat the computer. And that's basically how the computer can play. But what about if we want to play? So what about if we want the computer to guess our number, which we have presumably I don't know, devised? So we could write another function. So it could be a Boolean function again, which returns true or false. Should be I ask, I the computer, I ask stuff, and it will return true if I guessed the number. Or if I keep using we or I, but okay, so it's we. The computer is Mingw. It speaks in plural. We guesses the number, precious. So again, we can do this. Okay, how about we rename the functions? Okay, that's another thing about coding, is that you should preferably use the most appropriate names for functions and variables and whatnot. So ask is not something I feel is good enough here, so how about guess? And this way, if we rename the functions to guess, this code right here reads much better. So if human guesses, I guess. If human guesses, break the loop. If I guess, break the loop. So let's. And now it's much more readable. The code, I mean, is something that we that's very important, because again, it's in such a small program, it wouldn't matter that much. But the bigger your code base gets, the more important will be for you to, I don't know, for you to be able to read your code, because you forget. You'll keep forgetting if there's something you've written a long time ago, or if you have other people writing, like multiple people participating in the same code base. The more readable it is, the more helpful will be for the others that want to make changes, and for you to basically deal with the other people's changes and additions. So guesses and guess. Okay, this is much more readable. So if you want guesses, break. If I guess, break. Okay, but we don't have any code here. And in order for us to continue developing, I'll just comment this out. So this code right here exists, and I've seen it to work, but I'll comment it out in order for me to focus on this function alone. So I guess is the function that I'll be creating right now. So if you noticed, when I played with the computer, I kept asking like a bigger and a smaller number, and then one in between, depending on depending on the answer, if it's higher or lower. I had like two bounds in my head, an upper bound and a lower bound for the number of the computer, and I kept asking the middle number. That's called binary search, and binary search guarantees us that we'll find something in an ordered set, and the integers are an ordered set in no more than binary logarithm of this number attempts. So if you're not familiar with logarithms, I won't be explaining them here, but basically it's the inverse of power, like 2 to the power of 8, 2 to the power of 4 is, oh my god, so much calculations. 16, so the binary logarithm of 16 is 4, okay? The inverse of the power function is the logarithm function. Okay, so check out what binary search means, but binary search is basically looking for something in an ordered set. You probably know what binary search is. I don't know why I'm spending so much time on it. But okay, for the binary search that the computer will perform in order to guess our number, we'll use, as I said, upper bound and a lower bound. So those are two integers, and this is the minimal possible value the human number could have, and this is the maximal possible value the human number could have. And we just what should be used for the initial upper bound? Okay, how about we play on even terms, so the computer can think of a number between 0 and rand max. So we should allow this to the human too, and we should a good part of I don't know games or software as a whole. How long have I been in Gamedev? Since 2006, I guess. So a long time. So a good part of any software that deals with humans, like end-user software, which is supposed to be used by non-programmers, I guess, and non-experts, is for it to have a nice user interface. So we make our user interface nicer here if we say, think of a number between 0 and rand max. Okay, I have done so too. The computer. Okay, so okay, so this informs the player of the rules of the game, I guess. So so what will the computer do when the computer tries to guess? So as I said, we have an upper bound and a lower bound, so we need to ask something which is in between. And so we have our guess here, which is upper bound. Okay, so something in between will be lower bound plus upper bound minus lower bound over 2. So in C++, this division here, what? Why is this red? I don't see a problem with this line of code. Anyway, so this line over here is division, and if you're familiar with other languages which don't deal with division like C++ does, you might say, but here this number right here can be fractional. But the thing is that C++ has integer division. So if we are dividing integers by another integer, the result is also an integer, and it's rounded down. So for example, let me have an example over here. So I just comment these things out, and I just type 6/3 new line. So 6/3 is a whole number of guesses, but okay, 7/3. So 7/3 is 2 point something something something, but since we have integer division, this should be just plain old 2. So let's compile. Okay, reference to lower bound is ambiguous. Okay, because we've included. Okay, so lower bound is actually a function which exists in C++. So by me using this symbol over here and also using namespace and that's one of the problems you might run into if you use this namespace stud like this, is that a symbol which you've defined can clash with a symbol from the standard library. So I have imported a symbol called lower bound, and we will talk about the functions from the standard library, but lower bound is a function from the standard library, and this symbol over here, my global integer lower bound, and the stud lower bound from the standard library have clashed. So I still don't want to type stud : every time, so I just I'll just rename the numbers I use like this. So low bound and up bound. It doesn't sound very good English, but it saves me time, you know. Okay, so this will compile now, and let's start it. Okay, our example was 7 divided by 3. It's 2. So 8 divided by 3 still be 2, even though it's 2.6 continuous. So it's rounded down. That's what I meant. So our line over here is the lower bound plus the difference between the upper bound and the lower bound divided by 2. So in our initial case, when lower bound is 0 and upper bound is the maximum number, it will be 0 plus the maximum minus the minimum, so the maximum over 2, so it will be just smack in the middle. But when we change those values, so we'd say our lower bound is some other number, this calculation over here will be basically the size of the interval, upper bound minus lower bound. This will be the size of the interval divided by 2, so this means the middle of the interval, and when we add lower bound to it, we offset it by the lower bound, so we offset it so it passes the exact interval between the lower bound and the upper bound. That's what I mean here. So what else? So that's the guess of the computer. So now we need to appropriately change the lower bound or the upper bound depending on the answer of the human. So let's do something simple. My guess is okay, so the computer says my guess is this. Now enter H for higher, L for lower, and what should be the name of the if you've guessed the number. So let's say the equal sign if I guessed correctly. Okay, and now okay, so up until now we've been only reading numbers from the standard input, but let's now read a character. So in C++, the character is represented by this type, char. That's the first syllable of character, so some people do call it char, but char is, I don't know, the accepted way of calling it. Anyway, so we can answer, and we can again using console in, we can read the answer. So now we have several possibilities for the answer. So if answer equals H, and note the single quotation marks here in C, single and in C++, single quotation marks mean a single character. So double quotation marks is a literal, which is a string, so many characters, and single quotation mark is a literal, which is a single character. So other languages like say Python or Ruby or JavaScript, they have other meanings, other distinctions between singular and double quotation marks. C++, single quotation marks, single character, double quotation marks, multiple characters or a whole string. So if the answer is if the human responded higher, so our number was too low. So if our number is too low, that means that we should adjust our lower bound. So that means that no number under our guess is the correct one. So lower bound can be adjusted to guess. Oh, I forgot we renamed it. So else, if the answer is low, that means that our number is below the guess, that the human's number is below the guess. So we need to adjust our upper bound. Okay, but here we can add 1. Okay, because we obviously haven't guessed the number, so we don't need to try it again. So what by this here, I mean that lower bound is lowest possible number of the human, and the upper bound is the one above the highest possible number of the human. So this means that setting our upper bound to guess excludes the guess here. Oops. So else the answer is equals, we glee, yay, and then return true. Else we say what? Because that's something that this program doesn't understand. Okay, how about that? Okay, we know the number of the computer, so let's say that we've devised the number 4,000. Okay, so they're asking us 16,000 something, so they need to go lower. 8,000, go lower. 4,095, go lower. No, that's go higher than 2,000. Go higher than 3,000. Go higher than this, higher than this, higher than this, lower than this, higher than this, lower than this. Oops, lower than this. Lower, still lower, and now they got it. Yay, the computer won. Okay, so now the computer can guess our number, and 32,000 was the its rand max, so that's the one above the highest possible value that then we can think of. So if we want to be more precise, we can just do, oops, not here, we can just do this. So that's the maximum allowed number, and rand also works like this, like rand max is one above the maximal possible value of rand. So we can uncomment this and we can have an actual game, and to have the actual game I just can comment this line and I wouldn't even know the number of the computer. So we build. Okay, we're thinking of the number 3000, and you will notice that since the computer always uses the exact same strategy, it will always take the computer the exact same number of questions in order to guess our number if our number is always the same. So the computer guessed, I didn't even count this number, but if we think of the number 4000 again, it will take the computer the exact same number of questions in order to guess it, and that's basically the binary logarithm of 4000 plus 1. Unless it's lucky, of course. So if you notice these numbers, there are powers of 2 minus. Well, the interval is powers of 2 minus 1. So our number could be one of these, and the computer might get lucky and actually ask it before the actual logarithm. 4000 wasn't this case. Anyway, so we're thinking of the number 3000 right now. So we're asking the computer something like higher, okay, lower than this. I want to do this, but I mistyped. Lower, okay, lower than this, it's 3000, so 8000. Lower, okay. I'm gonna have to try to be lucky in order to beat the computer, so lower than 4000. Let's go with 3000. Higher. Oh, I wasn't lucky. I increased my interval. The computer will surely beat me now. So higher than 2000 something. So 5000. Oops, not 500. Oh my god, the computer will kill me. Okay, lower than this. 5000. Higher. Oh my god. Higher than this. Okay, let's lie. Let's do something else. I'm going to lie to the computer. So our number is 3000, but okay. Let's see what this does. In the meantime, I'll continue guessing. So it's between 5000 and 8000, like 6000. Higher. Okay. How about lower? Okay, 7000. Lower, okay, lower, 6500, higher, lower, 6200, lower. Man, I keep getting unlucky with my guesses. Damn, unlucky again. Oh, it was higher than 6. Oh my god, I wasn't even paying attention. Okay, anyway, I stopped caring about this a long time ago. Lower, lower, lower. And it keeps repeating the same number, right? Okay, so we need to deal with this case. So it repeats the same number because the upper bound and the lower bound are one and the same. So, oops, I don't mean to close this, sorry, I mean to basically kill this. Okay, so first of all, let's make the possible numbers the computer may ask us a much smaller number, because we wouldn't want to deal with so many questions. So how about between 1 and 10? You see here, we still have rand max here. So we shouldn't be using rand max. We should be using which is a constant that we will define. Okay, so in C++ you can define constants like this. So const, then the type, then the maximal possible value, and we can just add 10 here. This means that this value over here, we cannot change it with code. If we try to do it, it will be a compilation error. So that's max number. And in order to make the game fair, we will also allow the computer only between 0 and this number. And we use this operator here, which is modulo. So this is the remainder of the division between this value over here and this value over here, and it's always between 0 and this. So by using max number right now, I can, when I release the program, I can change it to rand max, which is the highest possible value that we can use. But for now, we can just leave it like this for our debugging and testing purposes. So let's build again. Oh, I want to show you what will happen if we try to change this. So if we say max number equals something else, this should be a compilation error. Okay, you see on line 86, right where we're at, assignment of read-only variable max number. We cannot change it with code. That's the point. If we accidentally do it, everything will break. So better prevent the possibility of us accidentally changing it. Okay, so this is a small number, and here, when we enter this function after our previous, we don't need to do it here. So over here, we've either guessed the number or we adjusted the lower and the upper bound. And if the lower and the upper bound are one and the same, that means that we've exhausted all possibilities. So again, I keep typing the name I had in my head. I should have just used stud : in every possible example. Oh, I could have done something else too, like I could have imported just a particular symbol. Anyway, so if they're one and the same, that means that the human has lied to us at some point. So we can output something like this. Sad face. Even something else. And then we return true. And if you remember, returning true from this function means that the loop is about to break. So I guess. Oops. Use correct English, people. Okay. So the human has lied to us. We return true. This will break the loop. How about we build? Okay, so whatever. I guess it's 5. Okay, let's see. Lower, whatever. 2, higher, whatever. 4, lower, whatever. So it should be 3 right now, but we say it's higher or lower, doesn't matter. Oh, you're lying. Okay, the computer called us lying. That seems about right. Okay, so that's a very, very simple game of higher and lower. And that's basically what I wanted to do with this stream. So basically setting up the build environment and creating a very, very simple and silly game, text only, which basically showcases the main part of any game, basically, which is the game loop or the main loop, in which input is processed, output is produced. Again, it would be graphics in a better game, which we will eventually get to, but input is processed, output is produced, and there are certain conditions in which the loop is broken. So if there aren't any questions about this, okay, that doesn't seem like a question to me. So again, I'll remain in the chat for a while. I may restart the stream if there are some questions, but I think that this should be it. Or should it? Okay, let's do something else. Let's continue our development course, I guess. So we let's assume this is our released game, so we want to, we are done either for the day or with the game, I guess. So how about we upload it somewhere? And this is something very important when you're writing software and not only games. It's to use some kind of source control, and we'll be using Git for this one. So source control is basically a way to or versioning control or version control, all kinds of names are used for this. So it's basically a way for you to save your code in a certain state with some comments, and then when you make changes, you have like a history of all the changes that you've made, and you can basically consult the history. This is one aspect of it, in order to consult the history and review the changes. And another aspect of this is to basically have the ability to share the code. So if you and I are working on the same code base, on the same game, on the same software, we use some kind of versioning control, and when I make some changes, I upload them on a server somewhere, then you download them, and we basically work together on the same piece of software. So you probably are familiar with many source control software out there, but for this one we'll be using Git. So right now I don't have Git installed, so how about I install me some Git. And again, on Windows this is a lot of setup, but so Git you can download from just type, no, not GitHub, sorry. Okay, git.scm.com, you can download it. For Windows you do it like this. If you're on a Mac, I suggest you install Homebrew, or I think Macs have Git installed by default. But if you're on a Mac and you don't have Homebrew, just install it. So Mac for Git. I think Macs do have it installed. I'm not sure, but anyway, then that's basically what you need to type. Or you can just check if you have it by typing something like this, like git version or something. It will display something, or an error if you don't have it. And on Linux, you could have it installed. Again, type git version in order to check whether you have it installed, but if you don't, use your package manager, say okay, I don't need to say this. And if git version produces something, something will happen. So git, okay, I don't have it here. I prepared the installation. I do have git installed, but I don't have it in my paths. So just like we start the stream, I'll just update my version. It's outdated anywhere. So on Windows, okay, additional icons on desktop, I don't care. Windows Explorer integrations, no. Large file systems, sure, why not? Associate Git configuration files, sure. Use a true type font, okay, I don't care about this one too. Okay, the default one suits me. This is the Vim, the Git editor for commits and stuff like this. You could change it anytime, so the default is okay. Okay, these two will add Git to my Windows paths, and I don't want that. As I started the stream with this, I want to manually control my Windows paths, so choose this. OpenSSL is fine. And this here means the line endings, because Windows and Unix do have different line endings, and this option right here for Windows development is probably the better one that I found. So okay, Windows specific stuff. Mint is fine. Credential Manager, sure, yeah. The Credential Manager for Windows means that once you type your username and password for a certain repository, they will be saved. If you're the only one using the computer from this username, that's something you do want to check. So enable file system caching, sure. Symbolic links, nope. I'm not an administrator. That's another problem with Windows development as a whole. Okay, so it's installing Git, and in the meantime I'll check how my Ubuntu is doing. Do I have Git here? Nope, but as I said, I can just install it. Or install it. Yeah, sure, download all those packages. And while Linux is downloading those packages, I'll see what's going on here. Nothing, really. There's probably some question that I've missed. Really? This window isn't clickable. What happened? Okay, it started. No idea what happened here. Okay. It's downloading. Everything's downloading. Everything's working. Everything's installing. A lot of stuff is going on. So basically, Git is the most popular source control or version control system out there these days. Didn't used to be the case a long time ago, but now it is. And the cool thing about Git is that you have GitHub. And GitHub is, if you don't know about GitHub, I don't know what, well, I'm explaining it, but GitHub is a place to share code for open source software to exist. This is my dashboard right here, but you can create a GitHub account, or if you don't want to share your code, you can use Bitbucket. Bitbucket allows you to also use Git and also have private repositories. So I'm going to be using GitHub for the examples of this stream. So I'll go ahead just and make a new repository. So the name was Gamedev stream. Description. Okay, what kind of description do I want? I want some code for my stream about game development in C++. Something. Public. Create repository. And now GitHub and Bitbucket will do this too. Will tell you what to do in order to push an existing repository or create a new repository and set it to point to here in order so the code will be hosted here in this particular one. Okay, I've installed it here. And now as you remember, we're using Mother, so we need to set it up. So how did we set things up? We did it by adding environments here. So Git, I guess. Okay, let's add this. The ship is on the bottom of the screen because my webcam broke midstream, and I, instead of troubleshooting and trying to fix it, I just added a picture over there. But in the beginning of the stream, people were actually able to see my face. But yeah, sadly something broke. So okay, set path and something that we're going to be using from here. Where is this thing? So you need to find where your Git installation is. Mine is here in programs. Yours would probably be in program files. So I don't want this. I want a bit more stuff. So okay, Git GUI. Okay, that's what I want. Okay, so I add this to path. Okay, now. Oh, I forgot to spell something. Anyway, so do I have Git now? Okay, so Git init. This tells us that we create a new Git repository here. So what files do we have here? So we have hello CPP and higher lower CPP, and the other files we don't care about. Wait, how come this is here? Did it create a copy? Okay, yeah, that Visual Studio Code did something that I wasn't expecting. So let's fix it. Not here, okay. Oh, too many R's. Okay. Anyway, so what do we have here? Hello and higher lower CP. Those are the files we care about. So we can just add them. So that would be git add hello CPP and higher lower CPP, and those are now ready for a commit. So this means that we've basically told Git that we want to commit those files in the near future. So if we type git status, this will tell us, okay, those files are ready to be committed, and those in red over there, they're not considered at all. So now we can make a commit with some message. -m means a message, so initial commit. Okay, and now we have these files only locally. If you remember, I hadn't set up anything. Yeah, that's bothface. That's correct. I haven't set up anything connecting this repository here that I just created with git init to the one in GitHub. So let's do this, and if we open here, oh yeah, that's bothface indeed. So if you open here, so push an existing repository from the command line. We can just copy this and paste it here. So push means that all the commits that we've made here locally, yeah, we're pasting stuff. So all this, okay, git remote add, that added GitHub as our remote. So that's where our pushes will go, and git push, those are branch names. So we're pushing to origin master, but this -u thing you need to do only once. So at least in the default git setup. So this will send our code remotely over there. Okay, and now you can check out here. We have those files in our GitHub repository over here. What's important about Git is that you set up your username and password, and I'll just go here and git not username but email and name in order for you to appear as the contributor here. You don't have to do it, and a default email and name will appear here, but if you want to connect these commits here to your GitHub profile, you need to add the email with which you register to GitHub and any name actually, but basically this with this git config. I'll just do it on Linux, you know, because I can. So let's try this on Linux. So we have this directory here in which we created our first attempt. So let's destroy it. And now we can use git clone, and git clone basically clones a remote repository locally here. So I can copy the URL here. I can paste it. What? Didn't I copy it? Okay. And now git clone actually created the directory Gamedev stream. And here we have our files over here, and we can actually build this game on Linux too. You remember the command line? G++ higher lower -o and HL. Now we can run HL, and we get to our familiar game. which OS. I'm using Windows, but this particular terminal here is on Linux. And now I see that we forgot to change something. We left the maximum number to 10. So that's even better, because I wanted to show you what to do in order to set up Git properly. So git config list will list my configuration, and you'll see that I have no configuration whatsoever. So git config user.name, that's my name actually, don't wear it out. Oops, I forgot the global part. Okay, so git config without the global will configure configurations for the current repository, and that's why I deliberately went out of the current repository in order to make configurations which are global. So and now if we list, okay, the name is correct, so git config user email my email git config, okay, that's correct. And now I can make some changes here. Again, I'm using Nano, but that's because I don't have Visual Studio Code on Linux, or I can use something. Okay, I'll just use some graphics editor instead of using Nano. Okay, higher, lower. Okay, and this will open the default Ubuntu graphics editor, which is graphical user interface code editor, I should say, which is pretty unpleasant, but it will do for our basic task here. So we want for it to be rand max. Ooh, and I found a bug too. We want max number here. Okay, so we're using max number appropriately. Okay, so I saved it. Let's make a build. Okay, and you can see, if you remember on Windows, the rand max was like 16,000, and here is like 2 billion. So it will be a long game until we finish it, but at least we know we made the appropriate changes. So let's see what's going on here. So Git Status shows us the current status of the repository. We have a file which is modified, so git add higher, lower. We add this file we'll mark it as a file that should be commit. So then we can commit. Now we fix that's commit message, which is also that's something which is important to have in order to have the history which is searchable and informative. So we fix the debug maximum number, I guess. Which we used only for debugging purposes. It wasn't our intention to release the game with this number. Okay, so we make the change. Now we want to commit. To push, and you can see that we only need to write push, and that's it. So push means that the commits we've made locally are going upstream or to the remote repository. Okay. I'm doing some magic now. What was it? Okay. Okay, I added that was my password. I do know my password, but I have some. You can read the GitHub documentation what other things apart from your password you can add here. So like user tokens or something. Okay, so I just added the token which I had saved somewhere else, which serves as a password. So and if I push again, it will ask me for username and password, and this will something that will help you. This is something that probably will help you on Linux, is how to save your credentials. And again, we can go. You can add a remote, like a global setting for GitHub. Git config global configuration. Credential helper, and store means that once you enter a username and password, they will be remembered, and you can add other stuff like store it just for a certain amount of time. But I just use store because I'm the only user of this computer, and I don't care if my user or password gets remembered forever. So again, I type this, I add my password, then if I push again, I don't get asked for username and password again. Anyway, that's for Linux or any Unix like system. So for Macs, this will help you too. So we have a repository with our code, and okay, I think that's a proper conclusion of the stream. And next time I'll be making more interesting but still text-based games, which will help us deal with other elements of game development. And after the 2 more games, I guess I have 2 more games in mind, text only terminal based, and then we will move to graphics, I guess. So that's for me. That's all from me for now. Thanks.